Hello everyone, thank you for joining us in this lesson. Today we are going to learn everything about functions. We'll cover interesting topics like expressions and statements, function returns, function parameters and signatures. Please stay tuned and enjoy the lesson. Let's start by typing a simple program to demonstrate the concept that we are going to cover today. I'm going to invoke our favorite Rust utility, which is cargo. And I'm gonna call this one function examples. So this is our project name, and I'll browse to the src folder and I'll open main.rs. So hopefully by this time you will be familiar with main.rs default file that gets created with cargo. It essentially just prints out a hello world to the terminal. But let's try and declare a brand new function. How would you do that in Rust? Of course, you start by typing the fn keyword, short for function, and I'm gonna name this one my function. The naming convention used is what we call snake case. Essentially, you separate words with an underscore. Okay, so moving on, then you'd open the curly brackets, and then you type in the body of the function. Let's write println macro again, and instead of using the println at line 2, we'll just use my function that we just defined here to do the same thing. Okay, so let's replace that with my function. There you go. Let me just browse to this directory here and do cargo run. Just gonna build the program, and there you go. So I've got a hello world here. This function is not really useful. Let's make it more interesting. Now, functions take what we call parameters. So between these parentheses, you can add additional parameters. And the correct term to use here is that each function has what we call a function signature. And in that signature, it's essentially the name of the function and the parameters that define that function. The parameters usually are strongly typed. So every time you add a parameter, you also have to add the data type. Let's in fact do this real quick. I'm gonna modify this one slightly. Let's say we are drawing on the screen. This function draws a pixel on the screen, and I'm gonna call an i32 here as a data type for x, and an i32 as a data type for the y coordinate. Now at line 6, I just want to make sure that I have my values defined as such, x and y, and let's call this function with a 10 and a 20 here. Let's run it. And there you go. So what we've done here, now this function signature contains two parameters, both signed integers. As you can see, we strongly typed these parameters. Now the values that go into these functions at line 2, we call them arguments. Let's say that this function now does some computation and then returns a value. Well, the way to do that is to make sure that you are actually defining the return value. In this case, I'll do an i32, and then I'll come to line 7 and maybe just increment the x as such. Save that, and let's use this in a println statement again. Or in fact, let's just maybe create a variable. Let's do this mutated x, and then println this new variable that we just created here. Cargo run. There you go. So it incremented x by 1 and it became 11. Let's try and do something interesting. We will combine what we learned in the previous lesson regarding data types with the concept of functions and the return values. So at line 6, as you can see, I'm asking this function to return an i32, which is essentially just a signed integer. What if we return a tuple, assuming that this function will increment the x and y? Again, imagine that my function not only draws a pixel to the screen, but it will also increment the x and y by 1 pixel. So essentially moving it in a diagonal fashion. Okay, so I'm going to ask the function to return me a tuple of 2 integers, and then I'll come in here at line 8. I'll increment the x and increment the y. Okay, now this function has a signature just as before. The only thing that we've changed is the return value to be a tuple of 2 signed integers. Of course, we have to do some modification here at line 2. We want to destruct that tuple into 2 different variables, mutated x and mutated y. And then in the println, we'll do the same thing. We'll add the additional placeholder here for mutated y. And let's run it. And there you go. As you can see, it's 11 and 21, while the initial definition at line 2 is 10 for x and 20 for y. There is an important topic here that we need to cover. At line 7 and line 8, for the eagle-eyed amongst you, you will notice that line 7 I've terminated it with a semicolon, line 8 was not terminated with a semicolon, right? So the difference is that this is a statement and this is an expression. Now the difference between the two is that a statement executes an action but does not return a value. An expression, on the other hand, evaluates to a resulting value. So the resulting value at line 8, a return of the incremented variables to the calling function. You can also have expressions as just concrete values. So if I replace this, let's just do this for argument's sake, right? So let's say I've got concrete values here. So that in itself is an expression. If I do cargo run, you will notice the value here at the command line, 50 and 51. So remember, expressions, they evaluate to the resulting value. Let's undo what we just written here, so it's nice and clean. Okay, so you can also use expressions by opening a new scope. So let's just do something interesting here, maybe x, y. I'm gonna call it this way, and then I'll open the curly brackets, and then in the mutated, I'm just gonna return a very simple tuple, 2 values, 50 and 51, and do println. Again, we're going to destruct the tuple here by calling the index this time. That's the x and that's the y. Let's save that and run it again. And there you go. X and y is 50 and 51. As you can see here, what happened is that we created a brand new expression with the curly brackets scope that has a tuple that gets returned to this variable that we created at line 5 called mutated xy. And then of course at line 9 we just print this variable to the terminal. Thanks everyone for following along, and I will see you on the next lesson.